All right. This stuff is not nearly as crazy. It's going to take some algebra. These are kind of messy to work with, but in terms of the actual answers and how things work out, this stuff is a lot better. So here's the idea. If I plug 2 in here, if I plug 2 into that original problem, so that would be 2 squared. So that'd be 4 minus 2 is 0. And if I plug 2 in down here, that'd be 4 minus 4 is 0. Uh-oh, I get 0 over 0. Indeterminate form. We cannot determine what the limit is when I get 0 over 0. So you're thinking, all right, bummer, now I got to do some work. Well, how convenient. This guy factors into x minus 2, x plus 1 over x minus 2, x plus 2. Because I should have said this. Oh, yeah, because look at that. We get some canceling, which means we actually have a hole in the graph. Remember when we get factor cancel, that's a hole in the graph? Factor cancel is a hole in the graph. So all we really care about is this part here, which is just the hole in the graph. See, if I plug the 2 in there, 2 plus 1 over 2 plus 2, so we get 3/4. So the limit is 3/4 because the hole in the graph is actually at 2, 3/4. Now, I'm not asking you what this is. I'm asking you what the limit is, but that's how you do it. So that's pretty simple. So when you get that 0 over 0, you say, oh, yeah, no big deal. How convenient, this one factor cancel. I can come up with a hole in the graph like that, which is the limit. Nothing to it. All right, these guys are a little bit more annoying. If I plug 5 in here, I get 5, and then I get 1/5 minus 1 over 0. Oh, stuff. I did something wrong here. Oh, I know what I did wrong. This was supposed to be x approaches 0. X approaches 0. So as x approaches 0, if I plug 0 in there, I get 0 over 1/5 minus 1/5. Uh-oh, I get 0 over 0. Indeterminate form again. All right, these guys, unfortunately, are really messy. To clean this up, so I got 0 over 0, indeterminate form, literally indeterminate form. So I have to, what the heck? Clean these up because I can't determine the limit. Now, you're thinking, wait a second. We did an entire unit on this in Algebra 2 last year. You've got fractions within a fraction. This is called complex fractions. So here's what we have to do. We have to make this into 1 fraction over 1 fraction. Remember, 1 fraction over 1 fraction so that you can multiply by the reciprocal of the divisor. So let me see. Who would be I need to make this guy into 1 fraction. So who's my common denominator? Whoops, I shouldn't have done that. So my common denominator is going to be 5 times 5 minus x. My common denominator over here is going to be 5 times 5 minus x. All right, which piece of the common denominator is this guy missing? This guy's missing the 5 minus x. So I have 5 minus x. Because remember, I mean, just check it out. If I reduce this, cancel, it cancel back to 1/5. Okay, which piece of the common denominator is this guy missing? This guy's missing the 5, so it needs a 5 on top. So now we can clean. So now you can say, oh yeah, now I've got a common denominator. Whoops. So now I've got a common denominator like this. So check out what we've got. 5 minus x minus 5. Any other cleaning we can do? So 5 minus x. So let me see, 5 minus x minus 5. Oh, so the 5's cancel. It just leaves negative x. So now finally, we've got 1 fraction over 1 fraction. So we think back to our Algebra 1 days, or Algebra 2 days. So now I can multiply by the reciprocal of the divisor. And when you're doing these problems, we should always get some cleaning. So how convenient, the x and the x are going to cancel. So we're left with, it's got a negative on it, So how about this? 5 over 5 minus x over -1, which would really just be negative 5 minus x. So this is annoying. We had to take this guy, go through the whole process of getting a common denominator to make it one fraction over one fraction so that we could multiply by the reciprocal to clean it up. So the problem turns into, what's the limit as x goes to 0 of -5 times 5 minus x. So now when we plug in the 0, we get -25. So the answer turns out to be -25 because we had that complex fraction that we had to clean up, just like we used to do in Algebra 2. Had an entire unit on it in Algebra 2. Okay. All right. How about something like this? You say, if I plug 6 in there, I get 0. If I plug 6 in there, 1, square root of 1 is 1. 1 minus, whoa, I get 0 over 0 again. Once again. Indeterminate form, you got 0 over 0. When I plugged the 6 in there, it made 0 over 0. Indeterminate form. So these guys, and I think you did this in Algebra 2, these are the problems where we got to clean this up. So we're going to multiply by the conjugate of the part that's got a radical. The conjugate meaning we change the sign in the middle. So we're going to multiply by the conjugate of the part of the radical part to try to clean it up. And you've probably done this. You probably did this in Algebra 2, but we're multiplying by the conjugate of the part with the radical. And the fun thing about this is multiplying by conjugates is nice because the whole thing about conjugates is this. Like if you said x minus 2 over x plus 2, they're conjugates because they're a binomial, and the only thing different is a sign in the middle. So that makes x squared minus 4. The middle part always cancels. So all we really need to worry about is multiplying the first part. So we multiply the first. So that's going to make x minus 5, and then multiply the last. So that's going to make -1. And then somebody says, oh yeah, that was no problem. But look how ugly this numerator is. Look how this thing's ugly. This thing really hurts my feelings. Okay, because now we have to FOIL this out. Well, here's what I'm going to say. I'm kind of lazy. I am not going to multiply that out because I'm so lazy. I'm just going to hope that something fun happens and that it cleans up, because that is just really crazy looking. But then you say, hey, look, how convenient. X minus 5 minus 1 simplifies to x minus 6. And then you say, whoa, how convenient. X minus 6 cancels. And so we're left with the square root of x minus 5 plus 1. So when you're doing these problems with the radicals like this, you should always get a whole lot of cleaning like this. Should always get a whole lot of cleaning. Now, sometimes it's going to be in the denominator. It'll be 1 over, but it always cleans up. Now, when we sub in 6 minus 5 plus 1, so the square root of 1 plus 1, so the answer is 2. So a little bit trickier, but takes a little bit of algebra, but you're capable. You can do it. Okay, we are going to ask you to memorize these two functions, right? Or these two limits right here. If you have sine x over x, that always equals to 0. And then this 1 minus cosine right here. Okay. So if I'm looking at something like this, what the heck is the limit here? Well, if it was only sine x over x, I know it would oh, I just messed this up. I got a big mistake on here. I got a gigantic mistake. This is supposed to be equal to 1. That's equal to 1 right there. Okay. So yeah, that was a big mistake. That's equal to 1. All right. If these two guys are the same, then the whole thing is just going to equal to 1. See, it doesn't matter. It just says x. So it doesn't matter as long as these are the same. So you're saying, well, that 5x is trapped inside the sine function. So if I could turn this into a 5, then it would be sine of 5x over 5x, and it would equal to 1. So to turn that 2 into a 5, I need to multiply by 5/2. But remember from your algebra, if you multiply the denominator by 5/2, you also have to multiply the numerator by 5/2. So I've got the limit as x goes to 0 of 5/2 sine of 5x. And then 5/2 times 2x just makes 5x. So see now that these are the same, sine of 5x over 5x, that whole thing right there just goes to 1. So 5/2 times 1, the answer is 5/2. And I know a bunch of y'all are going to say, oh, I notice a pattern here. I know you are, so just relax. You notice a pattern. I put this problem down here. I don't know if this problem is going to work out nice or not. So let's see what happens. So hopefully I didn't write down a bad problem. And we will give you the identities. If you're given a situation like this, we'll give you the identities. Remember good old cosine A minus B? So cosine 3 pi over 2, cosine x plus sine 3 pi over 2, sine x all over x. Does this bring back memories? We'll check this out. What is cosine 3 pi over 2? That's 0. Sine 3 pi over 2, that's -1. So what do we end up with here? We end up with the limit of negative sine x over x. Well, sine x over x is 1, limit as x goes to 0, so that's just -1. So like I said, if we give you a problem like this where you have to do an identity, like your sum difference identity, we'll give you the formulas on that. So anyway, some of these, I mean, they take a little work. They take a little work here. This takes a little work, but they work out nice and neat. I don't think these are nearly as bad as the problems where you have to graph.